Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. I know you need This Is How We Do It because this is a poisson distribution, a poison distribution. And I know y'all don't like them, but they are awesome. Awesome. And we're going to take about 37 minutes to explain this 7-pointer. Let's get to it, shall we? All right, so we got a ferry carrying cars across a river. You really, for these ones, you really have to concentrate and get your mind wrapped around it, or you're going to screw it up. That I promise you. A ferry carries cars across a river. There's a fixed amount of time, t minutes, so we know poison is coming because it's going to be within an interval. T minutes between crossings. The arrival of cars at the crossing can be assumed to follow a Poisson distribution with a mean of 1 car every 4 minutes. 0.25 times t is going to be our mean. Since it's 1 out of 4. Let x denote the number of cars that arrive in t minutes. Find t to the nearest minute if the probability that the random variable x is less than or equal to 0.6. Well, we know that the probability that the random variable x is equal to x, little x, is equal to, and this is really, I always mess up this formula because of the m's and the x's. M to the x, e to the negative m, all over m factorial, baby. Yes? Is that right? No, x factorial. See, I told you I screw it up. It's x factorial. Loser. Okay, and we know that m, this is our m, 0.25 t, and we have to solve for t. And we know that the probability that the random variable x is less than or equal to 3 is equal to 0.6, which is also equal to the probability of that the random variable x is equal to 0 plus the probability that the random variable x is equal to 1 plus the probability that the random variable x is equal to 2 plus the probability that the random variable x is equal to 3. Giddy up. So then we also know that 0.6, and now we're going to go to mama, replacing x with 0 and m with 0.25 t. So I'm going to assume that you can handle that and kind of get to the gist here. And that would be e to the negative 0.25 t when x equals 0 plus 0.25 t times e to the negative 0.5 t for x equal to 1 plus 0.25. Oops, careful here. I messed this up when I first did the problem. T, I always mess it up. It's the whole thing squared. E to the negative 0.25 t, of course, is for t equal to 2, all over 2 factorial, which is dose, plus 0.25 t cubed e to the negative 0.25 t, all over 3 factorial, which is 6. And I'm going to solve this by graphing, so I'm going to clean it up a little bit. And I know you intelligent folks probably don't need to write out this step and can immediately go here, which is just fine with me. 0.6, negative 0.6, plus I'm going to factor out e to the negative 0.25 t multiplied by 1 plus 0.25 t plus 0.25 t, the whole thing squared, boys and girls, not just the t or the 0.25, all over 2, plus 0.25 t, the whole freaking thing cubed, all over 6, and parentheses. And then I'm going to graph it like I've graphed nothing before. In fact, I'm going to graph it so quick. Hold on to your socks. Hold on to your underpants. Ready? Boom! Chugga-lugga-lugga. There it is. Okay, and you got to be very careful entering this. Say yes. Yes, yes, yes. Okay. And I moved 0.6 over just so I could find the 0. I didn't feel like graphing two things because I'm lazy. That's how I roll. And our 0 is 12.8. Giddy up. So now we can say that t is approximately equal to 12.8. Don't lose a point, boys and girls. Read the question to the nearest minute, to the nearest minute. So that implies 13 minutes. All right, so that is part A. Did you enjoy it? I did. I didn't leave much room for part B. I'll do it in pink. I think I can fit it here. It is now decided by the king or queen of the ferry carrier that the time between crossings T will be 10 minutes. So part A is going to have nothing to do with part B. Well, a little bit. Well, no, not part A. This part will. The ferry can carry a maximum of 3 cars. Huge, huge. If you miss that, you're not going to be able to solve the problem. It gets lost, especially when you have to read all this nonsense down here. The ferry can carry a maximum of 3 cars on each trip. Okay? One day, all the cars waiting at 1300 hours get on the ferry. Okay? So all this is just a preface to let us know that for the problem we're going to solve, we're starting with no cars. Find the probability that all the cars that arrive in the next 20 minutes will get on either the 1310 or the 1320 ferry. So let's get a couple of things out of the way here. We're going to have x1 represent the number of cars on 1310 ferry, and x2, oddly enough, is going to be the number of cars on the 1320 ferry. Awesome sauce. And we know that both x, the random variables x1 and x2, are a Poisson distribution with mean 2.5. Where'd you get 2.5, Mr. Becker? Well, we know that m equals 0.25 times t, and we are told that t is equal to 10 because the king or queen got a little bit uppity, and that's what they decided. All right? Have we got that settled? Good. So, we have a maximum possible number of cars at 6. 3 cars each, 2 trips. Remember, 3 times 2, 6. Very good. Okay. So put your bootstraps on. Put them on. So the probability that all the cars will get on either the 1310 or the 1320 ferry. So I'm just going to say probability that all of them get on those ferries is equal to. Okay, so we have to think about combinations of 6 given our parameters. Okay, so the first thing I'm going to do is the probability that x sub 1 is less than or equal to 3. Right? So that would be 3, 2, 1, or 0 times the probability that x sub 2 is less than or equal to 3. So that takes care of all types of combinations, 3, 0, 3, 1, 3, 2, and 3, 3, and vice versa. Okay? Plus, now we haven't done 4 cars or 5 cars or 6 cars yet. So what if, because this is all less than, what if the first ferry has 4 cars? I'm out of space, so I'm gonna move this down here. So we're coming around here just to give me room, plus the probability that the first ferry has exactly 4 cars times the probability. Now, what are the possibilities for the second ferry? It could be 2, 1, or 0, so that's x sub 2 less than or equal to 2. So hopefully you get the idea here, plus the probability that x sub 1 equals 5, right, times the probability that x sub 2 would have to be less than or equal to 1. Yes, because then the only possibility would be 1 or less car. Yes. Plus the probability that x sub 1 equals 6. Yes. Times the probability that x sub 2 would then have to be equal to 0. Not less than or equal to, just equal to. Okay, and I will tell you that that is approximately equal to 0.668 rounded to 3 sig figs. Giddy up. All right. And hopefully you know how to do that. I'll do the first couple of stuff. On the calculator here. So we had probability. Menu, prob, distributions, Poisson, CDF, lambda, that's our mean, 2.5, lower bound 0, upper bound 3, okie dokie. Okay, and then I'm just going to go up and copy that because the first one is, it's the same thing, remember? x1 less than or equal to 3, x2 less than or equal to 3. So I copied it, and that's how I would do that. Okay, and I'll just hit enter so you can see. Okay, plus, and then you can type it in too. Although by hand on your calculator, you're probably better off going to the menu. But now we have equal to. Okay, I guess I'll go menu again. So probability, distribution, Poisson. So this is exactly equal to 4, so we have to use Poisson PDF. Yes. Lambda, always 2.5. X value is 4. Okie dokie. Crap. I'm going to have to enter that again and then hit times POISSCDF, right? 2.5 is my mean. Lower bound 0, upper bound 2, boom. Okay, so you keep going. What I ended up doing is I just entered, using copy and paste, I entered it all in. Here, let me hit this, and then you can see how I have them all. If you want to pause, I'll just scroll through here, and then you can pause to see how to enter them. La la la. Boy, this is kind of boring. Oh no, I guess it's going all at once. So you can see how I entered them with the multiplication and the addition. And maybe one day you'll be as good as me. Enter, ooh, I get the same thing. All right, so that, boys and girls, is how we do it. And with that, I'm going to say, this is how we do it. I am out.